Okay, so everybody's okay with this? You'll watch it on YouTube. A couple of things that we wanted to do, guys, with you is go over, as I said, a couple of motor stuff. Um, I don't have a whole lot of time, guys, to cover motors. Again, I really refer you to, if you want to learn a few things about, for example, disconnect for a feeder, motor feeder, overcapacity device for a feeder, multiple motors on a feeder, disconnect for a motor, overcapacity device, fuse or circuit breaker for a motor, magnetic starter for a motor. All this stuff, if you want to have a really good presentation, encourage you to visit my YouTube channel. Go under motors, the playlist motors. There's at least 10 presentation detailed how to size all what you need about motors. So these are what we picked, a couple of things, guys, for you. We picked adjustable speed drive because they're becoming big deal, and I'm sure a lot of you guys deal with the VFDs. The trick of VFDs, there are two, I'm sure all of you guys work with motors, right? Some type HVAC equipment. So there are two ways of starting and stopping any motor. You can start it across the line, and good luck if you have a 100 horsepower motor at 480. There will be a big impact on the grid or on the distribution system in your building, right? Or you can soft start that motor, or you can VFD that motor, or you can voltage reduction. They call it voltage reduction in the motor. VFDs, as you guys know, the way we specify, putting my engineering hat, the way we specify the only time we specify a VFD on a motor is if you need speed control. That's the main part. I mean, you don't want to put a VFD on any motor if you don't need to speed control this motor. If you want to, with the speed control, you can ramp, as we all know, you can ramp up your motor, so that will be soft start on your equipment, on the mechanical equipment, on the grid, right? Soft start, there's no impact on the power distribution system in your building. Ramp it up, come up to speed, and when it shuts down, you can ramp it down, so that also have less impact on your mechanical equipment and electrical equipment. So that's ramp up, ramp down. Soft start can do that. VFD, of course, do much more than that. It can speed control. You can run the equipment at multiple speeds. Who cares? I always say, who cares? You can control the temperature in this room, right? With air handling unit, by controlling the speed of the air handling unit blowers, you can control the one way of controlling the temperature in this room. So here's what they define: an interconnected combination of equipment that provides means of adjusting the speed of mechanical loads coupled to the motor. Adjustable speed also can have auxiliary electrical apparatus. You can have with adjustable speed, because with VFD you can reverse the motors through the VFD. You can interconnect it with like you do with the PLCs, and you can get any signal to do anything almost in that one. So we picked that one for you because it's familiar. Controller VFDs is one type of controlling the motor. The other type of controller, as we saw across the line, we call them NEMAs. And if you guys, NEMA 1 through NEMA 9, and you can go and find them online, or if you come to this DeWalt, that's what I like about the DeWalt, guys. You can find all the NEMAs and what NEMA you can fit with what horsepower at what voltage. Single phase or three phase. So really cool. So from NEMA 00 all the way to NEMA 9. The problem with NEMAs, as we all know, they're across the line, no voltage reduction. So the inrush on the motor is so huge if your motor is high in horsepower, and that could dim or dip the voltage, number one, and make nuisance tripping for certain things in your building. So the two ways. The second one is the controller. That controller, as I said, you can start, stop a motor. If it's high-end controller like VFD, you can ramp it up, ramp it down, you can control it. If it's low-end controller across the line, it could be as simple as a fan in a bathroom, snap switch, that's a controller. And you go the next step higher, is magnetic starter. You push a button, start, stop, and you start to stop the motor with no voltage reduction, no inrush reduction, no torque reduction. So that's a few things, guys, about the motor controller, and I'm sure, does everybody understand all these terminologies, inrush over motor and all this good stuff? More or less, if you're working, guys, around motors. MCC, you guys, I'm sure you have MCC somewhere here. There are two ways. If you have a mechanical equipment or process equipment, all of them are motors, you need controllers. There are two ways of assigning these controllers. I call them the poor man's way and the rich man or woman way. The poor man's way is you throw all your disconnect magnetic starter or VFDs on the wall, with a gutter at the top, and you tap from a feeder, right? You bring a feeder, you can do that, tap from that feeder, and feed multiple VFDs or multiple magnetic starters with their own disconnect, an overcompression device, and overload, and you feed multiple motors or machines. That's the foreman job. Cheap, easy, you throw them in the wall, they're contained separately on the wall. The other one is, the better one that a lot of us do it, and I've done a few of these for wastewater treatment plants, they love it. You can group all your motors, the controllers for the motors, all your controllers for motors in one big piece of equipment with an overcompression device and a disconnect in it, and that's called an MCC. If anybody worked on MCC, I assume no, nobody, I'm sure a few of you guys work on MCC buckets. You throw the bucket in, and the bucket has a controller, the overcompression device, and you can use it as a disconnect. So that's what an MCC being able, what's the advantage of that? As I said, it's high, expensive. The drawback of having an MCC, it's more expensive than throwing a bunch of magnetic starters in the wall with a disconnect and controlling the process. What's the advantage? You have all your control in one place, all bussed together really nicely. You can do a control line. You have a control line in the MCC that you can control all these VFDs in much easier, better way than if they were scattered all over a wall in your building. Any comments, guys, about these? Any comments? We grabbed these from the NEC. A couple of them for you. When we talk about motors, guys, there's so many motors, special motors. For example, AC equipment, the code, if you have a compressor with your motor, if you couple a motor with a compressor, the whole combo acts differently. So the smarter than Chad decided to group them in a 440 article, standalone, instead of putting them in 430, like a fan motor, a blower motor, anything that has a compressor, refrigeration equipment, and chillers and so forth. When you have a compressor coupled with it, it acts differently. The motor will act differently. So they put them in a standalone motors, in a standalone article. There's a couple of articles that cranes, for example, have some type of motors that control them. Fire pumps is a big deal here. So this is just a few lists of places where you can have equipment from motors to capacitors to special type of motors and so forth. Hazardous location, we'll talk about how do you install a couple of motors in a hazardous location and so forth. So that's just a FYI info. When we deal with motors, guys, I don't know how many of you guys deal with sizing the equipment. Probably most of you do the maintaining the equipment, you're an electrician, but when you become a master, which I hope it's the goal of each and every one of you, at least a journeyman, right? So becoming a journeyman, a master, or power limited technician, I think it should be the goal of everyone, unlicensed and my fault. Then you get into sizing equipment. When we size the equipment for motors, guys, there are tables and in Article 310.15b, you have to take the amplicity and size them based on 310.15b. 310.15 16b. 310.15 16b. Based on this table, guys, you can size the conductors for your equipment. And if you mind me grabbing my NEC code book quick here and taking your quick. Do you guys have your codes with you? No? Okay, you don't have to. So this is where most of the sizing happen. I'll take a second here to. If there's one table you should know and never forget, it's that table here. This is what we call it, table 310.15b16. You size all the conductors for any type of motors, any type of equipment based on this table. For example, suppose I have a motor, and my motor was 10 amps, right? 10 amp motor, 3-phase, 10 amp motor. Motors are continuous load, so you have to multiply it by 1.25. The code says if it's continuous load, and the definition of continuous load, you have to run fully for 3 hours or more, fully, at full load. So if you have a motor that's running at half load, that's not continuous. It has to run fully. So if the motor is 10 amp motor, it has to run 10 amps for 3 hours or more, it becomes continuous. So say I have a 10 amp and I need that 10 amp motor to size a cable for it. 10 times 1.25, right? That'll give you 12 and a half. 12 and a half. Motors, the terminal on the lugs of the motors, that's going to be on your master exam annual journal when you guys sit there. No question asked. The motors, the terminals on the motors, as well as the circuit breaker, the lug terminals where you tie the conductor, rated for 75. So I'm going to go size based on 75. Look how easy that is. So we have 12 and a half, right? We have 12 and a half. Here's my 75 here, and I need 12 and a half motor, and I'm going to go to 75. Technically, I don't like to use number 14, but technically you can use number 14 for this motor. So okay, now if you ask me as an engineer, the minimum conductor that you should engineer, not code-wise, minimum conductor you should use in any commercial industrial field is number 14, number 12. Don't even go to number 14. But code-wise, technically, I can tie 3 conductor, 3-phase for a 10 horsepower motor that's running continuously. That will be 20 amps. Number 14, 3 of them, good to go. Any question, any comments, guys? Take a 100 horsepower motor, and the reason I say I'm not saying horsepower, guys, I'm giving amp because of ease of calculation. Let's take a 100 amp motor. I know they're rated in horsepower, but I'm sure I'm using the amps just for the ease of calculation. 100 amp multiplied by 1.25. That will give you 125. Let's go to 125. So I'm going to size a cable for 125 amp, 130, perfect. Then I need 3 conductors. Number 1, done. This is one of the most important tables that you guys are going to be encountering. No question asked. Any comments, guys, about this? And oh, by the way, this, if you haven't seen this, this is the copper area. And remember, Chad is an engineer, and we don't buy the equipment, we design it, so we're always sizing this on copper. But aluminum is good. If you want to size this on the aluminum, you're going to go to this side. It will give you, for example, to the same application, if we're using aluminum, we're going to use 20 here. I need a 20, that will give you number 10, aluminum. God forbid if you're using aluminum. And the other one, look at this one. For the 125, I need to go all the way up to here, and that will give me 2 aught. From number 1 into 2 aught if you go to aluminum. And we all know what the advantage of aluminum, the weight. The weight is really cool and cheap. The disadvantage, of course, you need bigger conductors, and they're not as safe as copper in terms of short circuit. They melt. The melting point is lower than the copper. Any questions about this table? This is must know for motors, for anything else. So that's the table that we use. Okay, let me minimize my and go back to my PowerPoint presentation and go back here. All right, 15. I'm going to add 310.15B16. Or B is the whole article. We add 310.15C. I don't know if you're using, I don't know how many of you guys, 310.15B has multiple tables. The one that I showed you is 16. The 310.15B16, that table is 95% of the time you're going to be in this table. Any one of you guys work on medium voltage equipment here? Raise your hand. Medium voltage like higher than 600 volt? No? Okay. Unless you work on higher than 600 volt, 99%, 95% of the time you're going to be 310.15. Or if you guys have an engineering department and when you become a master, you can calculate the amps yourself. You can do calculation for the amps. And I like always, which is 310.16, I like to always throw that one here and go back one step. If you don't like these tables, under engineering supervision, right in here, you can, under engineering supervision, you can permitted C to calculate the ampacity and the rate. Conductors shall be permitted to be calculated at this formula. So take this home and go put it in your computer and size based on this formula. People always laugh at this one, guys. We have, when I worked at the Elder Beckett, and a lot of engineering firms also have it, is a software called AMP Calc. AMP Calc, you can plug any size cable, and you put the cable in any configuration, underground, overhead, grouped together in ducts, conduit ducts underground. and it will tell you how much current this conductor can carry under these circumstances. That's where this becomes really interesting. So I thought just to highlight that one here, and if you're using flexible cords, which sometimes you have a bus duct, you tie from the bus duct with a flex as-school cord, and you tie to the equipment, right, to a disconnect. You're going to go to table 500.5. So that's basically where we get all our conductors. But the challenge is the amps. The problem with motors, they don't come with amp rated. Most motors come with horsepower rated. And there's so many manufacturers of motors, guys. So the smarter than Chad decided a long time ago to group all these motors based on voltage and horsepower and assign to them a code full load current value that will be typical for almost all the manufacturers. And that's where they came up with these tables. Remember that 100 amp motor that I told you? Where did they come up with the 100? Where did I come up with the 100? Well, most of the time, usually they're rated, almost all the time, they're rated horsepower. You're going to go to the NEC code and find the equivalent of the horsepower in amps. I like to go to the three-phase 430.250, guys, and give you one very quick example, and I'll come back. So if you go to the NEC, so we're going to go to 430. If you go to Article 430, my friends, go Texas 430. Let's go actually start with here because it's easier to come from the back. There you go. These are the tables that you are going. I'm going to go to the table, this one, 250, because it's the most notoriously famous. You guys are in a hospital, you deal with a lot of lead-based equipment. This is the 430.250, for example. Most of the system you have probably encountered is going to be three-phase 480. So suppose that I have an air handling unit, and the air handling unit has a motor that's rated for 100 horsepower, right? 100 horsepower motor, and we're burning it. Most likely, if you have a motor like this, the best system for it will be 480-277. The best doesn't mean you can't run it at 288-120. Here's my 480-277. The full load for this one is the fourth, is right in here. So this 100 horsepower motor, based on the code, will be running 124 amps. So what do? You multiply it by 1.25 and you size the conductors. Multiply it by 1.15, size your disconnects. Also based on this and the horsepower and the voltage, you can size your magnetic starter. You can size the overcome protection device. If it's inverse type circuit breaker, take this, multiply it by 2.5, size your inverse type circuit breaker. So this number becomes very, very important. And if you can see, guys, they give you the voltages here slightly less than the nominal voltage. Manufacturers rate the equipment slightly less than the nominal voltage in this case, taking into consideration voltage drop. So 460, when you start with 480 at the substation, you go all the way 100 feet, you're going to lose some voltages here. So this motor that's rated for 460 can run efficiently at 124 amps as long as you give it 460 or higher, or around 460. Any comments, guys, about using this table, where they got these? Anybody have ever been here at this table? You guys been? Yes, no? No? Yes or no? May I ask how many of you guys raise your hand? How many have been there? Just to give an idea. Okay, more or less. Okay. If you are to sit for your journeyman exam, you must know this table inside out. No question asked. I mean, if you're, and it's really easy. If I want to run this motor at 208, if my motor just click at 208, you go over here. Look why it's important to run at a higher voltage. Look at the amps. Can you see the difference? The same amount of work. If you lower the voltage, it gives you a huge amount of amps. Who cares? I always say, who cares? Look at the conductor that you need to carry these amps compared to this. So bigger conductor, bigger conduits. Every time I say that, the people say, well, Chad, job security, and they need us. You know, other than job security, it's not efficient system. That's why it's almost all. It's a good idea and when we designed to go to the highest voltage that we can get, which is 480 for the most part in the US. Any question, guys? These are the most common motors you're going to encounter, induction motors. So that's one way of dealing with this. Now these are the table. Now what happened? So this is the first one. What happened if you buy a motor that's rated with amps? You can. You know, we buy motors from all over the world now. What's the motor rated with amps? You're going to go to the tables based on the voltage, and you're going to find the equivalent horsepower of that motor. It's easy. If it's a 100 amp motor, I can go to the table, go to which voltage is 480, so that will be 460. Keep going until you hit 100. If it's not, if you can't find 100, you can 90 and see 120. You're going to go to the next one, and you go across, and you find the amps of the horsepower of that motor. Interpolated. I don't know how many of you guys have done interpolation. When you have a number between two numbers corresponding to another two numbers here corresponding to two numbers here, and there's one number between these two, I can find the other number. So I don't want to go there, but the way I always encourage people, if you know the horsepower of that motor, the amp of that motor, just go to the next horsepower. If it's 90 and there's no 90, go to 100 and they'll give you the horsepower for that one. Nameplate. If you have a low speed motors running at, most of the motors that we run, guys, is 1800 RPM. The synchronous speed, 1800 RPM, very common motors. 3600 RPM, the synchronous speed. These are very common equipment that run at 1800 RPM synchronous speed. So 1725 is the RPM that runs at. If you have a slow motors that run at 1200 RPM, less than 1200 RPM, then they don't want you to use the code. They want you to use the full load amp that's printed on the nameplate of this piece of equipment. And also, if you have a high torque motors or multi-speed motors, these are the applications where this would be for your master exam. They will give you a motor. That's how we trick you. They give you a motor, and the motor is 1200 RPM. Running at less than 1200 RPM. They say a motor is running at less than 1200 RPM. Find the disconnect for this motor. So you go to the tables, wrong. You have to use a nameplate that they give it to you. So it's a tricky one. Who cares about all this? Because of full load amp, per carat, we can size conductors, we can size switches, disconnect switches, and we size overcompression device. The full load amp, that's the one that comes with a nameplate. The only place we size it, guys, is what we call it the overload. The overload. The only place that we size is right here. The overload is from the nameplate full load current. So every motor that you can buy is going to have two full load amps. One coming from the NEC code book and one printed on the nameplate of that motor. The one from the NEC code book, this guy, you can size everything. The only thing you use the nameplate full load amp is to size the overload. And anybody wonder why? Why do they want you to use the overload to size the overload? You use the full load amp to size overload. Because full load amp is the overload is very important, guys. It can smoke your motor. If you don't size the overload right, it could smoke your motor. So they don't want to depend on the NEC code book full load. They want you to use the manufacturer specific full load amps for the overload. Any comments? Any questions? So I hope I'm not going too deep into that one. Marking on motors by code. Now this is for manufacturers, not for us. We don't make motors, right? Manufacturers have to give you their name so we can sue them if something happens. Let's say sue them. You have to have their name. You have to have the voltage and the full load current. If you guys can see that one, you're going to have the voltage here and the full load current, their name. How about the frequency? And how about the three phase? You need to know if it's single phase, three phase, DC, AC, full load, speed, temperature, and the installation, class of that motor and the ambient temperature that this motor is working at. So these information, if you look at the nameplate of a motor, by code, these all information have to be listed for every motor. Couple of other things that they can give you too. Time rating. Um, is this motor, for example, you have an air handling unit. The blower on the air handling unit is continuous duty. That can run continuously. There are motors that can run for cycles of 30 minutes, 30, 15, 5, 15, 30, or 60 minutes. If it cycles on and off. Most of the motors that we use in construction industry for the most part continuous duty. Unless you have a specific function, most of them are continuous duty. Horsepower, you need to have also, you would hope that they give you the horsepower and the nameplate. If you have multi-speed motors, anybody worked on multi-speed motors? They are becoming obsolete now with the VFDs. With the VFD, I can have an induction motor, one speed, and can control its speed from 0 all the way to higher than the synchronous speed even. In the past, before the VFDs, they used to have multiple windings, guys, and by wiring certain windings, it gives you step 1200 RPM. Another set will give you 2400 RPM. So different windings, that's multi-motor speed. If this one is to be encountered, you need the horsepower for each speed if it's changing. Welders, exception, you don't need horsepower for them. This is my favorite. Locked code letter, locked rotor current. This is needed for anything rated a horsepower or more. We'll talk about this one. Wound rotor, please delete that. It's not. Get used to the code, guys. There's always a rule, and there's always 5, 6 exceptions of the rule. That drives people nuts. So, for example, if you have a wound rotor motor, anybody worked on a wound rotor motor? All these equipments, guys, a lot of them are not with the advantage of the VFD. This was another good motor that you can speed control it. With the advantage of the VFDs, induction motors are becoming superior. Even DC motors, they still have their application. But induction motors, you have VFD on any piece of equipment. You can speed control it. That's why DC was superior for AC for a long time, for motor-wise, because of speed control. VFD solved this problem. Design letter, B, C, or D. 90% of the equipment that you guys are going to be designing is going to be design B. Is the kind of a general design code. Anybody knows what the difference between code letter and design letter? It has to do with code letter is the air rush. So when you have a 100 horsepower motor, when you push the button to start it across the line, a huge amount of current is going to momentarily, for no more than 10 seconds, it's going to be sucked out of the system to energize and magnetize the motor so it can start. The question always asks, who cares? Imagine the example that we have just said, guys. If you have take a 100 horsepower motor. Here's my 100 horsepower motor. If when I start this baby across the line, it will be taking almost 6 times more amps than it's running. So to start a 100 horsepower motor, I need 600 amps only for 10 seconds though. Who cares? If you have seen sometimes an air conditioning kicks in and the system dims down, right? That's because we're pulling so much current, it created so much voltage dip into the system, and the lights got smaller amount of voltage across them, so they went down momentarily, and then they go up. That's bad news for the electrical system, so we're going to reduce it. That's as a function of a code letter. Design B, C, and D, if you're familiar with them, guys, they design, always, the motors, guys, are mechanical machines. What do we use motors for? We use them to drive mechanical equipment. Now, the mechanical equipment they have loads, mechanical loads in it. The mechanical loads are different. Having a motor that drives an elevator is different than a motor that's driving a conveyor. It's different than a motor that drives an air handling unit, fans. So based on the function of the mechanical load function, you need to match it with a design. For example, some motors have very high starting torque. If I want to start something, a high starting torque, or a low starting torque, or variable torque, electrically speaking, we care less. Mechanically speaking, you can, if you put high sparking torque on equipment, you can shock the equipment and break it into pieces, right? You pull something so hard, if it's too heavy, you can shock it and break it to pieces. So this becomes a big deal, big deal. Most of you guys, since you're in the building industry, right? We're in the maintaining of building industry. Most of the time we're in design B. Design B have a medium starting torque, medium inrush, so good enough for starting equipment and good enough for running the equipment. Comments, questions about motors? I've done with it elsewhere, guys. We teach motors in 3 months, just to give you an idea. There's a lot of things about motors. This one, if you are to sit for a German exam, make sure you know this, really cool. There's the design letter and there's the code letter. The code letter is the inrush current. How much current when you start the motor? This motor is going to suck out of the system for only 10 seconds until it comes up to speed. If it's across the line, if it's not across, if it's VFD, by the way, these will go way down. If you're soft starting it with a VFD or a soft start. The design letter has to do with the torque. You need to have high torque, variable torque, and all this good stuff. Take this. Suppose that we have a D, design letter D. Design letter D, the worst scenario for design letter D is 4.49. So if you have 100 amp horsepower, 100 amp motor, 100 amp motor, if you multiply it by 4.49, that will give you 449 amps. Just 14 seconds, 100 amp motor, design code letter D, if it says code letter D on there, that can pull out of the system 449 amps only for no more than 10 seconds. Again, the problem is 10 seconds not a whole lot yet, but that's enough to screw up your system. Then the equipment affect the function of other equipment. So this, get used to this. When you do the calculation, it's a range. You always go to the upper limit because that's the worst scenario, right? Worst scenario is upper limit. Any question, guys, about this? How to use this table? You take that number to find the full load amp. You take that number, and let me see if I can get my my pointer here. You take that number and you multiply it by the horsepower. Disregard here. No. Okay. If you take, I abuse my computer a lot with these. So you take here's that number, multiply, say if it's a 100 horsepower motor, right? Say it's just 100 horsepower. So you multiply this by 100 here. Okay, and then what voltage do you guys want to run it at? 480? 277 3-phase. So here's my 100. Divide this by 1. It's not sticking here. 1.75 because of the 3-phase multiplied by 480. It's not giving it. That's called the abuse of the technology, huh? All right, let's use this marker here. All right. So many markers, huh? Okay, get this one. That's a cool one. Multiply this by, what did you say, 100 horsepower? Here's my 100 horsepower motor. Divided by the voltage. You guys told me you need a 480 volt. Here's a 480 volt. There's a multiplier for the 3-phase, so that's always 1.73, and then you multiply everything by 1,000. This is how you find the starting current of a motor, a 100 horsepower motor. And so you take this upper limit number, multiply by all this, divided by the bottom, that will get you the starting current of this motor. And if you don't believe me, read what they say. These numbers are given in per horsepower, kilovolt amp per horsepower. So that's why we have to multiply by horsepower. So if you were to sit for a gentleman, get used to this, because that's what you're going to be doing. Any comments, any questions, guys, about this? Comments, questions? Okay, moving on from the sizing into the ventilation. When you deal with motors, guys, I always tell I'm a master electrician too, and I wire. I always say, guys, 80% of the electrical work is mechanical. You agree with me? 80% of what we do as electricians is mechanical work. That 20% is which color wire goes to which terminal. That's only the knowledge. The 20%. How to torque the terminal. What is this has to do with electricity? I can get a mechanical guy to torque it better than I do. You know, so that's most mechanically. Because of this, mechanical stuff about motors is a big deal. We have ventilation and maintenance. You have to have adequate ventilation and maintenance for the equipment. Lubrication, replacing of the brushes. Don't have a whole lot of brushes now. And as exceptions, we have submersible type motors. Obviously, there is not a whole lot of ventilation for a submersible pump. You guys have submersible pumps? They don't need a whole lot of ventilation down there. They're self-cooled. But if you have motors, I always say that the most of motors fail because of mechanical issues. You know, lack of maintenance on them, the bearing on them, lack of cooling of the equipment. Most of the time, we came a long way, guys, of maintaining the integrity of the power system. The electrical problem with motors is lower voltage. If we single-phasing motors, we're really good about not single-phasing motors for the most part, or maintaining the voltage at a certain level, 10 plus or minus 10% of the nominal voltage. We're really good at that one. But ventilation equipment, you throw a fan in one corner and you just leave it there. You don't clean it. You don't do a whole lot of maintenance. Of course, it's going to fail eventually. Open motors. If you have an open motors, guys, and these are DC, the collector rings, that doesn't ring a bell for you. If you have an induction motor in an air handling unit, you're not going to have a collector, like collector rings and commutators. These are DC constant, should be protected so that the sparks cannot reach adjacent combustible material. The last thing you want to do is have a DC motor right next to it, something that could be ignited, and every time the bushings or if there's a spark, you're going to ignite the surrounding. Take this, installation of these motors on wooden floor or support shall be permitted though. So if you have an open, I don't like to spend too much time on it because you guys have DC motors here. Do you maintain DC motors in the place? Do you? Certain applications for cranes maybe, or for lifting things? What type of equipment do you guys use for?
Special equipment that we're using for the Refrig.
Okay. 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 Equipment, though, HVAC equipment, which is a major part of the motors, is for the most part is induction motors. Induction motors. Exposure to dust and accumulations. You need to take care of your equipment. If the dust is going to interfere with the operation of the equipment and make them overheat, you have to clean them. And you have to have a suitable type of enclosures for them. I don't know if you have a situation where you even have to pipe ventilated motors, enclosed pipe ventilated motors, enclosures you can use in very heavy, severe conditions where there's a lot of dust. And again, these are dust, but not combustible dust. Combustible dust that move you all the way to hazardous occupation. These are just dust. So if you have a very dusty environment, you have to choose the right enclosure. And if it's very severe, you have to have enclosure pipe ventilated motors. Do you guys have anything that enclosure pipe ventilated motors to the outside? So and then you get into the combustible dust or readily ignitable flying materials. Dust, if you have a dust that can ignite, that move you all the way into the class 2 and class 3 locations. Class 2 and class 3 locations. And we will touch on that one in a second. So a few things about that one. Single motors. We talked about this one, guys, when we size the motors. You take the full load amp, continuous duty, and you multiply by 1.25. So that's not a whole lot to it, and you size it based on that table. Here's what we're talking about, guys, is You grab your feeders. You look at your feeders right here. How are you going to size your feeders? How are you going to size the branch circuit? These are your branch circuit that's coming in here. All this, you're going to take a 1.25 and multiply it by the full load amp times full load amp. Full load current. I want to use the word full load current because then you see. But this is why it's very important, guys, to know the full load amp or full load current of a motors, because based on that, you can size the conductors coming to it, the short circuit. You're going to size the branch circuit motor conductors, which is the same here and here, controller, and overload protective device. The overload protective device. When you sit for a general exam, knowing how to size this one is a big deal. I know probably a lot of you guys don't get into sizing him at this moment. We maintain him, Chad. We change lights and receptacles and everything else. But I don't have a whole lot of calculation for this, guys, but I invite you to visit my YouTube channel. And there's a lot of stuff about how to size each and every one of them in details. But it will take hours, though. I counted 185 hours I have on YouTube. It will take you for 8 hours a day. If you work, it will take you 23 days to listen to them. 23 working days, 8 hours a day. Now, who's going to do that? I don't know. Trying to convince my wife to watch one of them. By code, if you have a motor and the motor is a horsepower, the horsepower is more than 1 horsepower, then you have to provide some means of overcompression device on it. A means of overcompression device. If it's more than a horsepower, if it's less, it's optional. Here's one way of providing overload. Everybody knows for motors, because they're very expensive, guys, air handling unit, chillers, rooftop units, crack units. You maintain data centers here, so you have cooling, computer cooling units. So these are equipment, very expensive pieces of equipment. So you're not going to depend on a fuse or a circuit breaker to protect this equipment. We hope not. So what they do is they have multiple protection. Protection number 1 is a fuse and circuit breaker. That's the upper level for short circuit and ground fault. You have a fuse or circuit breaker. You go down to protect it from single phasing or to protect it from being overloaded. You put a tiny little device, electronic or a heater, that protects the motor from overload. So if something to jam on this motor before it starts smoking, if you don't have an overload and you jam a motor, the circuit breaker will wake up and trip eventually. But by that time, smoke will be and probably fire will be engulfing the whole motor. So yeah, great, your circuit breaker wake up, but we lost 100 horsepower motor. Now you have to go buy a new one. So that's why the smarter than Chad decided to put the overload protection. And almost all of them on equipment that has motors. It was expensive. It's not like the light. Why don't we have an overload protection at this fixture here? We don't have an overload protection now, and we depend on the circuit breaker to protect that, right? Yeah? Tiny? Disconnect, but does it come with overload? You have to have a disconnect with it by the new code, but you don't have to have, you have a tiny little overload. You can if you want to. Fuse each and every one of them? Yeah. Oh, okay. So it's special, that more protection, but you don't need it by code. On the primary or the fuse, or where do you put them? On the ballast? The line with the ballast, you fuse them?
It was used as disconnect before the double disconnect was used for common.
Okay, so is this your standard, guys? To fuse all of them?
Yes.
Interesting. But you still have the disconnect now. The disconnect is good. That's a whole different animal, the disconnect. But you can. It's not. What we're saying here is this is required. This one is optional. It's your choice. You can put as much protection as you want. Okay, so if you have a motor, and to protect the motor, guys, they allow you, there's a few things you have to know. If the service factor is 115 or greater, temperature, as well as all other motors. Service factor 115, the way I understand it, if you have a motor, 100 horsepower motor, they allow you 15% extra to overload that motor. Not continuously though. So if that's the situation, then they allow you 25% more on the overload. So if your motor is a 100 amp motor, nameplate, you can set your overload electronically or heater up to 125 amps. So you allow the motor to overload 25%. Why? Because it's designed to be abused and used 15% or greater. If your motor is temperature rises 40 or less, if it's by design, it's designed that the temperature rise doesn't increase more than 40% plus the surrounding ambient temperature. Then also 100, meaning it's not going to heat up by design. Then the same thing, you can overload 25. All other motors, that's not any of these, then you only can allow 115%. Meaning, if you have a 100 amp motor, you put 15% extra on that motor to overload, because you have to allow the motor to overload momentarily, right? Or for a while. Otherwise, every time there's a little bit of load, it's going to trip. It becomes awful. So that's how you size your overload, and all based on very important concept: nameplate full load amp. Nameplate full load amp. Any comments, guys, about overload? Overload. You can use a fuse and overload each ungrounded conductor. You overload, if you're using, can I use a fuse and overload? Yeah, you can use it, but if you're using a fuse, typically we don't use a fuse on major motors as an overload. You have a separate overload as part of your starter to protect the motor, better protection. But for a smaller motor, you can use a fuse, then you have to put it in every ungrounded conductor. Anybody have used this, guys? Corner grounded delta? Corner grounded delta. Anybody use with corner grounded delta? If you use a corner grounded delta, it looks something like this, a 3-phase motor. And they take one phase, typically phase B, and they ground it. So here's your phase A, and phase C, and phase B here. Anybody worked in a system like this? Corner grounded delta. It's a delta, they ground it to stabilize the voltage to ground. Now phase B is a grounded conductor, right? It's grounded. It's tied to the ground. But if you were to use it, then you have to also have a fuse. A fuse, if you're using an overcurrent protection device, only if you're using the fuse as an overcurrent protection device, you have to put the fuse here. By the way, if you're not using this system, if you're not using the fuse as an overload protection device, you do not need to put a fuse in a grounded conductor. You don't have to. So if that fuse, if I have my own electronic trip overload, I only need 2 fuses for this system. One for A and one for C, and B will be, and instead of a fuse, they put a copper connector, just a piece of copper to tie it. It's a grounded conductor. Unless you're using it for an overload. If you're not using a fuse, there is a table where it tells you most of the time in every phase we're going to use it. For example, so you have one phase. It will tell you the number of the conductors that we're going to use. 2-phase system, 3-phase system. You guys are going to be right in here most of the time. It tells you which system. Most of the time you're in supply system. I have a 3-phase. I have a 3-phase AC system, and any 3-phase voltage, meaning 208 120, 480 277, 240 120 3-phase, and you need one in each phase, one each phase. Any question guys about that? That's if you have a separate heater or a separate electronic device, not a fuse. Now, for motors, guys, we have 2 protection: overload and short circuit. This table will get you to size short circuit. And I always like to use an example. Suppose that we have 100. Let's go back to my 100 amp and I use the amp because it's easier. I don't want to go to the tables. 100 amp motor, and I need to size an overcurrent protection device for it. Your choice. You have 4 choices here: non-time delay fuse, dual element time delay fuse, instantaneous circuit breaker, molded circuit breaker, or God forbid instantaneous, or inverse type circuit breakers. Inverse type circuit breakers. Most of the time, guys, For smaller motors, you're going to be in this area, in this type of circuit breakers. Dual element time delay fuse is a good application. So let's size it based on all of them. So that horsepower motor, based on this one, you multiply by 300. That will give you 300 amp. Does that make sense? That will give you a 300 amp non-time delay fuse. If it's time delay fuse, your fuse is going to be 175. Make sense? Amp. And if you use an inverse type, I want to leave that one at the end. If you're using a circuit breaker, you're going to have a 250 amp circuit breaker. So here's my fuse, and here's my motor. There you're going to have an overload. I'm just showing a few of this. So you have your motor right there. So that fuse is going to be 300 amp or 175 amp, or if it's circuit breaker, 250. See the difference between what type? Anybody ever use instantaneous strip circuit breaker? Instantaneous strip circuit breakers, they're also called motor circuit protectors. Calmer Hammer has them. We have Calmer Hammer. All manufacturers make them. It's a special type of fuse that looks as short circuit. So the smarter than Chad decided, instead of having a full spiel in this type of circuit breaker with thermal component, if it's thermomagnetic, you have a thermal component and magnetic component. What they do is they have just magnetic component, so cheaper equipment, and they install it. That's why it's 800. So I need an 800 amp instantaneous strip circuit breaker. By the way, this is not a fake circuit breaker. This is, it's size-wise, it looks probably exactly like a 250 circuit breaker, but it's designed different. Nobody ever see when you go, it's ABC, you put it at A or B or C, adjusting by letters. Anybody have seen them? Circuit breakers. That's basically allowing, it's just protecting from short circuit. No overload whatsoever on that circuit breaker. Any questions about this table? Again, if you're becoming a journeyman, when you sit for your exam, that's it. That table you have to know it inside out. So I used the single phase, but you underneath it exactly the same. Three phase guys identical. The three phase is exactly identical. Squirrel cage design, B energy efficient. We have design B energy efficient, not design B. Synchronous. I don't know if you have synchronous motor here. That becomes on a higher voltage. Wound rotor motor and DC. All the different types of motor, AC, DC, and the synchronous, induction and synchronous. Again, most of the time you're going to be in AC motor other than wound rotor motor. Any comments, guys, about this table? Any comments, questions? Okay, dual. This is just a couple of exhibits, guys, from dual element time delay fuse. It really, if you have seen, this is how a circuit breaker, guys. Let me just, and I hope I don't sound too engineering here. Here's a circuit. Here's a trip curve. Another trip curve that you can use is no delay whatsoever. Here's another trip curve here. And just to give you an idea, here's a circuit breaker trip curve. Looks something like this. Oops, no, it doesn't go all the way there though. This one that you're looking, the first one, you're looking at non-time delay fuse. You see how it's closer here? It doesn't allow the motor to start. That's why we have to oversize it. Doesn't give enough time for the motor to start. Time delay fuse, it waits and waits, gives the motor more time to start. Inverse type circuit breakers gives it also more time, but it shoots all, it just gives a different shape. All these are basically different ways of tripping. By the way, going this way is the current increase. This is time characteristic here, current versus time. So if we have a dual element time delay fuse, you have two elements. One element will look at the overload, and the other element will look at the short circuit. If you have a huge amount of current going through the fuse, it will trip fast. If you have small amount of current higher than the rated amps, it wait for it could be a minute or two or three, and then it trips. That's an overload condition. So that's the two elements. time delay fuse. Disconnects. Motors, guys, are notoriously famous for having a disconnect. Here's the rule for disconnects. The rule that every motor must have its own disconnect within inside of the motor and within inside of the controller and within inside of the machine driven by the motor. Because we can have a motor here, and we have the controller there on the wall, the motor here, and the machine in the other area. So you can have, the general rule is to have a disconnect within inside of the three of them. That's okay. Within inside is 50 feet or less, no obstacles. So you have a disconnect there that disconnects the controller, the motor, and the driven machines. That's one. If you can't achieve this, then you have to have a disconnect for the motor, a disconnect for the controller, and a disconnect for the machine. That's another rule. The third rule is under, if because of whatever reason, usually industrial, commercial, industrial, they allow you to have a disconnect that you can lock in the open position in one location like the MCC. So you can go lock it. It's not within inside of the machine or the equipment, lock it, tag it, and then you can work on the equipment. So there's a lot of rules for the disconnect, but the ideal situation is to have the machine, the disconnect right next to the machine. So you can disconnect the machine, work on it. For us, the mechanicals, everybody else. Any comments, guys, about the disconnect? Disconnect can range from snap switch on the wall for smaller motors into a big circuit breakers in an MCC, into a NEMA heavy duty disconnect on the wall like this, into a plug for certain motors. The plug itself is rated as a disconnect. You can plug the machine on and off for smaller equipment. So a couple of equipment. So disconnect means capable of being locked in the open position. So again, if that's the situation, you have to adhere to the exceptions. The rule is you have to have a disconnect within sight of the machine, the driven machine, the motor that drives the machine, and the controller. Exceptions in industrialized location where maintenance is done by qualified people, you can have it in another location where you can lock it. So that's just a few things about the controller, the disconnect, the controller. General use snap switch or NEMA, heavy duty or non-heavy duty on the wall. Plug in. Portable equipment, you can plug them in. A lot of machines, if it's especially portable equipment, plug in, that will act as your disconnect. A lot of equipment and appliances, a disconnect would be rated, the plug is rated as a disconnect. Any comments, guys, about the disconnects? So the typical rule is the disconnect next to the equipment. The exception is to have the disconnect somewhere else. In either way, either wherever, especially if it's out of sight, you have to be able to lock it and tag it. If it's not because of the code, because of ocean. You can't work on an equipment if you can lock it, tag it. Because we're tired of people leaving their hands behind when they're fixing equipment, right? Machines start, chop somebody's finger. VFDs, couple VFDs. Okay. That's all what we're going to talk, guys, about motors. We're going to move to HVAC equipment. Any comments? Anybody has anything they want to share about motors? Anything? There's really, I know you guys, I assume that you do maintenance on motors. We have HVAC people who maintain the chillers, I assume, and the air handling unit. Or do you guys do it? Is that part of what you do? Okay. So chillers and equipment and so forth. But I assume you guys troubleshoot the control circuit and the power circuit for equipment. And air handling unit is not working. It's part of your job to troubleshoot it, right? Why it's not working. This book has a guide. I'm sure everybody has. There's a lot of guides how to troubleshoot the control circuit and the power circuit for equipment. It has a really nice guide, step by step, how to troubleshoot the power circuit and the control circuit. So it's I encourage you again. I don't work for the guys, just FYI. And I don't get commission out of it, too. But there's a couple of things that's really interesting. Okay, moving to any question about motors? Any anything? Any comments? Anything about the motors? 306. Okay, and I thought we were going to be able to finish all this stuff. Man, where does the time go? Unreal. Okay, any motor that has a compressor with it, and you couple a motor with a compressor, they act differently. So the smarter than me, they lump sum them in an article that's called 440, air conditioning and refrigeration equipment. Because they act differently, they come, because the refrigerant, really, the refrigerant cycle in these equipment, they act differently, they are completely different, they act different. If you put a blower, a fan blower is completely different than a compressor. So they act differently, go together. There's a couple of concepts you have to guys know. They call it branch circuit selection current. HVAC, let me summarize HVAC equipment for you guys. If you have an HVAC equipment, chiller is notoriously famous. Rooftop units. Chillers, rooftop units, condensing units. Two things you have to understand. They came, for us, electrically speaking, when we size things, electrically speaking, when we size things, you have to understand actually three things. Number one, you need to size a conductor. There's something called minimum circuit ambiguity stamped right on the chiller, the compressor. It's called minimum circuit ambiguity. You grab this number, say 50, and you go to the table, retail of 50B16, and size a conductor. No multiplication needed. The manufacturer, they rate, it's called minimum circuit ambiguity. They stamp it on the nameplate. You grab that number, go to the code, size a conductor. If it's three-phase, 3 conductors. If it's two-phase or two hots, 2 conductors. If it's single-phase, 1 conductor and 1 neutral. That's the conductor size. Now the second thing is the fuse size or the circuit breaker. Right on the nameplate of these HVAC equipment, they will tell you, I need 100 amp fuse or 100 amp hacker circuit breaker or both. So if in the nameplate says 100 amp fuse, you can't put a circuit breaker unless it says 100 amp fuse or circuit breaker. Then you can put a fuse or circuit breaker. So then you don't do any calculation really. They size it for you. So that's the second one, and the last one is a disconnect. HVAC equipment need a disconnect, so you can use a current that comes with the equipment called rated amp current or branch circuit selection current. These two values, pick up the largest, you multiply it by 115, and you size your disconnect. So if it's 100 amp, say 100 amp HVAC equipment times 150 give you 115 amp. The next standard disconnect is 200 amp. So you throw 200 amp in it. So any comments, guys? Oops. Any comments? Any questions about that? So that's just summarizing here. We have branch circuit selection current. They use them instead of rated load amps. The way I understand it, I'm not an expert in HVAC. When you put a compressor pump with a blower, they can work harder than if you just have a blower by itself. Because of that, the current can be higher than rated load amp current, the rated load amps for each one of them. So when you design your branch circuits and overcomplication device and disconnect and controller, you're going to use either the rated load amps of the equipment or the branch circuit selection current. Either way, it's going to be on the nameplate. You're going to use the branch circuit or the rated load, whichever is larger, you pick it. If the branch circuit says 100 and the rated load amps on the equipment say 120, you'll use 120 and size your equipment is 120. Okay, so that's basically value circuit current equal to or greater. So it says the branch circuit selection current equal to or greater than the rated load amps. So and again, the reason why they have this equipment have two currents because the way they act when they work together, these two equipment. And that's the special type of the motor. We have they call them hermetic refrigerant motor compressor combo. They're enclosed in the same housing with no external shaft or shaft sealed. The motor operating in the refrigerator. So they're acting as a unit. Unlike a fan on a roof, where it's acts by itself, right? It's not tied to any refrigerant cycle or anything else. Because they're combo, they act like a standalone combo. So they're different than just a motor by itself. Am I getting into the messages? They act differently than a motor. with these equipment, they have something, guys, called leakage current detection interrupter device provided in the power supply cord or plug set, senses the leakage to the ground and trip if there is leakage to the ground in the system. Rated load current. Compressor, again, we have a motor compressor operated at rated load. This is the current that you can get if you give the motor the rated load, the voltage and the frequency that's supposed to work on. You get something called rated load amps. Rated load amps. A couple of related articles, guys, that also related to it. If, for example, you have a chiller in a hazardous location, what do you think you need to do? You need to go consult the hazardous location for the wiring methods, the wiring equipment, and so forth that you can use in these areas. So this just talks about the branch circuit selection current, and it could be, if you're going to choose the largest of the two, compressor having protection system, ruled for use with compressor, permits the continuous current in excess of the specified percentage on these values. Anyway, so just to summarize, guys, the way I understand it from electrically speaking, two values. Choose the largest size, everything based on the largest of the two. Without getting into too much of the details. Disconnect means, and horsepower rating. Disconnect means for HVAC equipment, when you size the disconnect there, and as a matter of fact, also the motors. When you have a disconnect for a motor, they have two sizes for it. There's the amp size, 100 amp disconnect, and the horsepower size. It's say 50 horsepower. So you have a horsepower and an amp size, especially for HVAC equipment. The amp size is easy. On a 100 amp chiller or condensing unit, you're going to put 115 amp disconnect. You can't find 115 disconnect. What do you need to do? Go to the next standard, which is 200. Horsepower, you're going to take some of all the equipment. The way they do them, guys, they take the locked rotor of the equipment, the blower, the compressor, they take the locked rotor current. So if you grab the rotor and lock it and you turn the switch on, that's how much current that locked rotor current, the starting current, another term for it. Add them all up and go to these tables in the back and size the horsepower based on the locked rotor current and also based on the running current, and choose the largest. Choose the largest. If it's not corresponding to a value, what do you need to do? You go to the higher. I like just to show you just a quick, because that's really interesting how they do them. If you come over here, we were exactly in this location here, my friends. If you look, this is the table where you use the locked rotor current. So just to give you a quick idea, suppose I have, here's my 480 system. Let's just look at the 480 system, which is 460. This is the locked rotor conversion, locked rotor. So you have a machine, and you added the locked rotor current for each one of them. Added them all up inside this machine. Okay, add. And suppose that we came up with, when we added them all up, let's just say we came up with this value here, 290 amps. So the locked rotor current for the compressor, the blower that comes with the compressor, all these equipment added up, we added to 290. That will correspond to a horsepower disconnect 40 horsepower rated. Does that make sense? 40. That's how they use it. So they add the locked rotor current, and then they come to this table under the right voltage. Under the right voltage, because you have to have the right voltage. So if it's 290, it corresponds to a 40 horsepower. So when you go buy your horsepower motor, you're going to say, I need a horsepower, 100 amp horsepower, or 200 amp horsepower, depending on the size, and also rated to interrupt. It's not going to explode if somebody's accidentally disconnected under load. Rated for 40 horsepower. Any question, guys? Comments about HVAC rating? If it was a different voltage, take this. If I was a 208, and suppose I added, they all added to 135. I added the lock structure current to 135. So you're going to keep going down, down, down. Now it's 135 is between these two numbers, right? Between 102 and 140. You have to go to the next standard, which is, so I can't go to the 102, so I have to go to this, and this will correspond to this value. So I have to have a disconnect rated for 7.5 horsepower motor, plus the amps, if it's like 100 amps, 60 amps, and so forth. Any comments, guys, about this? That's probably a journeyman sizing. So I think we went deeper a little on that one. So if it doesn't correspond to a value, you go to the next value based on these tables that we were looking at. Disconnect for, we're still in the HVAC equipment. You have to disconnect for cord connected equipment. You can use a connector or attachment plug and a receptacle as a disconnect means. Most of the time for smaller equipment, good example is window air conditioning, refrigerating equipment, freezers, drinking fountains, and all this good stuff. There's some info that you need to pay attention to window air conditioning. But plug-in is not your chiller. You're not going to go plug in your chiller. Right? Your chiller is going to have a horsepower amp rated disconnect right next to it, on it, or next to it. That's for smaller equipment. Disconnect. The disconnect for the equipment, guys, within sight. Within sight is defined by the code as not further than 50 feet and no obstacles. So it could be 50 feet and I have to jump 20 feet to reach it. That's an obstacle, right? But no obstacles, straightforward, no climbing over, under, or in between, and not further than 20 feet. Readily accessible from the air conditioning or refrigeration equipment. You can put them on or within the air conditioning or refrigeration equipment. So chiller, you can put the disconnect right on the chiller. And in 2008, they came up with, say, if you have a disconnect right on the chiller, don't put the disconnect on the nameplate of the chiller. The last thing you want to have a disconnect and mount that disconnect on the nameplate of that chiller or compressor. That's locking. Your disconnect have to be able to be locked in the open position, and the locking mechanism have to stay in place regardless of the lock-in. I don't know if you remember, you guys use these portable locks when you can, if you're working on a lighting fixture like this, you can go to the panel. You don't have to disconnect. It's better to disconnect it because that's where they came up with that little disconnect for these double-ended fluorescent lights. But see, if I want to troubleshoot this receptacle here, or change it, I don't have by code to disconnect it. Well, it's a good idea to disconnect it. So what a lot of us do, they have a portable disconnect, right? You guys use them. If I want to change this receptacle, I go turn the circuit breaker off, lock it with my little lock, right? Portable ones on the circuit breaker so nobody can energize it. Come over here and change the receptacle. That doesn't apply for air handling unit. Air handling unit, you have to go to disconnect it. If it's right next to it, work on it, lock it, tag it. And the locking mechanism have to be in place regardless of the lock in it or not. If that makes sense. That's what we said, guys. When you have an overconfiguration device for the chiller, it's going to be the maximum fuse right on the nameplate. And if it's a circuit breaker, it will see a hacker. Heating, air conditioning, rated, type. And almost all the circuit breakers, if you look at them, they say hacker on them. Large circuit breakers, meaning you can throw this one in HVAC equipment. Otherwise, if it's not a hacker, you're not supposed to. And the reason for this, because of the way the HVAC equipment consume power, the impact on the electrical system. If the circuit is not rated for a hacker, it could nuisance strips and not protect you properly, or not protect you properly. So if I have an equipment like this, my friend, and here's my equipment, come up with a circuit breaker. Here's my HVAC right in here. I can have a 200 amp circuit breaker here,
and it has to be hacker. Hacker, they spell, is that what the term that they use? Yep. HACR. Oops. HACR, hacker. If it says a fuse, then you have to put a fuse.
Now what happens if they say a fuse and you have a circuit breaker panel? What would you do? You can't put a fuse in a circuit breaker panel, right? So you put a circuit breaker in the panel, and you bring the feeder right next to the HVAC equipment, and you put a fuse disconnect right next to it, right? Solve the problem. You give them their fuse right next to the equipment. Instead of having an unfused disconnect, now you have a fuse disconnect. And you continue to have your own circuit breaker in your panel. You're not going to go change the panel just to match an HVAC equipment that says need a fuse. You pull the circuit breaker to protect your cable, right next to the equipment, fuse disconnect, based on specification of the manufacturer,
and off it goes. Off it goes. When we size the conductor, guys, right here, that conductor, you take it based,
exactly like motors, based on 125% of the compressor rated load current or the branch circuit selection current, whichever is greater. That's the funny thing is, again, about the equipment. They have two rated load amps and branch circuit selection amps. Branch circuit selection amps is either equal to the rated or higher. So
you choose it, you multiply it.
Overload protection, there's a few things about overload protection. You can have a separate overload relay, and if you look at that, you can size it at not more than,
look at the value they use for HVAC equipment.
Most of the time, guys, the HVAC equipment comes with its own controller overload protection. We're really, electrically speaking, we don't mess with it. We might provide a disconnect, fuse disconnect right next to them, or we just provide a power port, which is a circuit breaker with a feeder tied to their disconnect that's already on the equipment. Most of the time. If we are to get involved in sizing the overload, here's an example, 140% of the rated load amps.
So they allow you to go to 140% on a relay overload. If you have thermal protector with motor approved to prevent dangerous, you can have thermal protector integral with the motor to protect it on a second way. A third way is a fuse with circuit breaker, but don't go higher than 125 amp, or some type of protective system.
So some type of protective system with the equipment. So different ways of protecting them. Most of the time, they have their own protection, so you don't have to mess around with it. Come as a package, especially with chillers and compressors and so forth. Any comments? Any questions? Comments, questions?
A couple of things about sizing them. If you have equipment,
but look at the amps. These are smaller equipments, guys. 15, 20 amp branch circuits, not cord and attachment plug connected. The overload, single phase circuit permitted, shall be permitted based on A or B in this one. So basically, the circuit breaker on, look at these systems. They're smaller systems, guys. Single phase first. Then you can see the voltage. They're all single phase. 280, 240, 120. The circuit breaker protects you.
Provide overcurrent protection device as well as short circuit protection on these equipments.
Comments, questions? Comments, questions?
Smaller systems, smaller equipment. If you have a window air conditioning, the branch circuit
requirement for these, for window, a couple of things about these. Look at this, the condition. So these are window air conditioning, single motor unit, plug-in, cord and attachment plug. You have to have it. But look at the limitation though. Do you see a three-phase chiller here? Where you can plug a three-phase chiller. The limitation is single phase. Look at the limitation of the amps and the voltage, guys. You can't go higher than these voltages and these amps. The total rated current in the air conditioning nameplate rather than an individual motor current is used. Overcurrent device does not exceed the basically of the branch circuit conductors or the rating of the receptacle, whichever is less. So if I have a 20 amp circuit breaker and a 15 amp circuit, a 20 amp circuit breaker, and a 15 amp receptacle. Now you're limited to a 15 amp because the receptacle is a plug into a 15 amp receptacle. So whichever is smaller. If you have a dedicated circuit, and we use it all the time, guys, you know how much is related. So suppose that you have a circuit breaker plug here, and you have a 20 amp. If you have a dedicated circuit for a window air conditioner, and you're plugging it in right here, plug, then you're limited to an 80%. So on a 20 amp, your air conditioning shall not be more than 16 amps, right? Plug it in, dedicated circuit, one receptacle, 20 amp, circuit breaker, you're limited to 16 amps. If your circuit breaker is 17, if the rated load amps on the equipment is 17 amps, you can't feed it from a 20 amp. This is for a poor man's job if you have a circuit that's feeding other loads. So suppose that I have a circuit here coming over here and feeding the air conditioning plug. I'm plugging my air here, and also somewhere here going to a light, feeding multiple lights, coming here and feeding a receptacle, right? It's shared by multiple things, right? Tank circuit. Then you are limited to 50% of the circuit breaker. If this circuit breaker was at 20 amp, then your conditioning cannot be more than 10 amps. The problem is how are you going to enforce this? It's a portable equipment. People can't plug it. When you design system, guys, if you use, I don't know if you use window air conditioning here or not. I assume you don't do it. So this is just for your journeyman exam, will you? Remember these, especially these two values. You love them. I don't know why. If you have a dedicated circuit, cut it by 80%. If you have a shared circuit with others, 50% on your journeyman exam. Disconnect means attachment plug or cord, single phase room up to 250. So you can have the plug as your disconnect means. Readily accessible and located within 6 feet of the floor. That disconnect and the plug. Approved manual operation disconnect means installed in readily accessible location within sight from the room air conditioning. So if you have a plug-in, you can use a plug as your disconnect. You can have a disconnect attached to the equipment, a switch that's attached to the equipment, but it has to be accessible and not more than 6 feet off the floor. You can have a receptacle 8 foot and down and act as your disconnect receptacles plug disconnect. Leakage detector and arc fault circuit interrupter in these equipment, only single phase, only plug-in connected equipment. You have to provide either leakage or arc fault circuit interrupter on them. You can have them as part of the attachment plug in the power supply within 12 feet of the attachment plug. So I'm getting into this one. Right now, if you use this in residential, guys, you are plugging it into a GFC and arc full circuit interrupter anyway, especially if it's 120, all the 120, 20 amp and 15 amp have to be arc full circuit interrupter protected in residential. So earth leakage or arc full circuit interrupter protection in these equipments. Okay, that's all what we're going to do. The only thing, guys, for you, what we highlight is what's important for the German exam. There's a few other things. I like when I deal with it, you can deal with chillers and compressors. Really, the most important thing on the chiller is nameplate shows the fuse, stick with the fuse. You have to have a disconnect within inside of the equipment. Very important. And also the nameplate shows something called minimum circuit amplicity. Take this to town and go buy the conductor based on 75 degree and size it if you have to. Transformers. I'm not going to ask you if you guys use transformers. The building, almost every building has some type of a transformer in it. Almost all the buildings come up 480. You have to, in the US, you have to bring the 480 down to 208, 120 so we can feed the convenient receptacle that we burn at 120, right? These receptacles here. Otherwise, really, in a lot of the Europe guys, you use a system 400, 230, then you don't need a transformer in a building like this. Just think about it. If you're burning if this receptacle here is burning at 277, Do I need a transformer that takes 480 to 28120? It eliminates the whole stability drive system for you. It's interesting how to think about it. When you run these conveyor receptacle at 220 or 230 or 240, eliminates the transformer. So in our case, we have a transformer. We use them a lot, almost always, to take the 480 system into a 28120, right? Very common application for them. You guys have your power, you have 13.8 coming here, so you take also the 13.8, 4160, the high voltage down to 600 volt or 480, 277 and feed your building. That's another set of transformers, high voltage. Transformers, they can be individual transformers, single or multiple phases, identified by single nameplate unless otherwise indicated in the article. So basically, this covers all three-phase and single-phase transformers. I don't know how many of you guys have seen this table. We have the other table, yep. Anybody have used this table, seen this table before? This is when you sit for your master exam, make sure you know it. So keep this one for you, really for your licensure. This is really interesting. Primary voltage. So take this. Here's my transformer, and I'm showing only one winding on the primary and one winding on the secondary. And I like the 100 amp transformer. Just let's say this transformer is 100 amp. I have 100 amp here on this side, and I have 10 amp on this side, right? It's a step down transformer. This side is 13.8 K, right? You guys have 13.8, and this side is 480, right? 480 system. This is very simple, and I'm showing only one phase. That you can imagine three phases are going to be the same. So here's my transformer, and I put the amps just to make it easy because I don't want to make it fast for calculation. So I'm going to go size a fuse. That's this table, sizing a fuse or circuit breakers. So let's go to the high voltage side. If I go to the high voltage side right in here, I need a fuse right in here. Okay, so let's say the voltage is the primary voltage over. Can you guys see this is over 600 volt? Am I using a fuse? Yes, Chad, you're using a fuse. All other locations, this is in a location where exposed to the public, not all other location I can apply to it. Your default is right here, and I'm using a fuse. Look at the fuse. So what do you think the fuse size is going to be? 30, right? Everybody knows what 300 is. 300% is 3 times 10, 30 amps. So this fuse is going to have a 30 amp medium voltage 15K fuse. Cool. That's what this directly from this table. Or default is any location, not supervised ones. Impedance most likely the default is less than 6 unless you know otherwise. And I decided single-handedly, Chad, to use fuses. I could have used circuit breakers, God forbid, and I have 660 circuit breaker. Okay, so that's the primary. If you go to the secondary side is less than it is less than 600. Right, 600 or less. I'm using a circuit breaker, so my multiplier is 125. So this fuse is going to be 125 amp fuse. 125 amp fuse. Straightforward, done. This is the most important table to size fuses for a primary and secondary or transformer. What I highlighted, guys, is the most common application. Supervised locations. Is another set, but the most common, if you don't know anything about any location, that's where you default. Any comments, any questions about that? This is this table. If you go to the second one, this table is this is very common for you guys. I know you use it all the time. This is if you have a 480 system here, and on the secondary you have 208. Very common application for it. 208 on the primary, 480 on the secondary, 208 to feed your receptacles and some lights. You want to burn your lights at 120. This table only if all the system is less than 600 volt or less, both primary and secondary. That's where you use it. Okay, so let's use the same example, guys. Here's a 10 amp here and 100 amp here, and size for the same example. Take this, primary and secondary protection. Your default is always here, more than 9 amps.
here's my multiplier on the primary, 125. So this fuse here is going to be, what's 125 times 10? What, 12.5, right? It's not a standard, so the next standard is 15 amp. Why do I go up? Because if you guys look at note number 1, and if it says if it doesn't correspond to a standard, so could you please don't go to the bar and start drinking and be mad because they don't make 12.5 amp fuse for you. Don't go spend an arm and leg for busman so they can make you a special fuse 12.5. Go up already. Right? So that's the primary. The secondary, guys, look at that. I'm defaulted to here, more than 9 amps, right? I'm sorry. I should default. My default is going to be right here. I apologize. This is where I want to protect both primary and secondary. All right, let's use this then default. Then in this case, I X this one. I need 2.5. So 10 times 2.5, that will give you 25 amps, right? So I hit the jackpot here. 25, right? 2.5, 25 amp. 25 amp, that's a standard fuse. By the way, if you don't know if it's a standard fuse, where do you go? There's an article 240.6 lists all the standard fuses that are approved by the code. 240.6. The second one here, I'm going to use 125. So this is 125. That will give me 125 amp. Done. So I have my 125 amp on the secondary and 25 amp on the primary. Good to go on this. I call it receptacle transformer because it's mostly, you need this one only if you're feeding receptacle. A building like this, why do you need a 28120? You can run air handling unit at 480. You can burn these babies at 277, right? So why do I need it? The only time I need a 28120, or especially 120, is the receptacles. Almost all equipment can run them at 277 or 480. Okay. If you have an auto transformer, there is a couple of things that you have to keep in mind. For example, they don't want you to fuse this. God forbid you go fuse this area here. Imagine fusing that common area here. So each auto transformer shall be protected individual overcome protection device shall be rated at 125 amp of the rated full load input amp. So a couple of things about the auto transformer. Do you guys use an auto transformer a lot here? Buck boost transformers, mismatch. Buck boost transformers, if you buy, especially if you buy an equipment from Europe that's running at 220 and your system is 240 or 280 and you want to up the voltage, that transformers becomes very handy. These transformers. Okay, I don't want to get into the calculation for the buck boost, guys. It's a whole lot of different animal. Paralleling operation, can I parallel two transformers to give me more power? Yeah, we do it all the time. So permitted to be operated in parallel and switched as a unit. Overcome protection device, if you do it this way for primary and secondary protective devices over 600 volt based on this table. For the primary and secondary, so you have to have an overcome protection device based on the table. But can I put two transformers tying together phase A, B, B, C, C, and run the whole building with it? Yeah, they use it. Utilities use it all the time to get you more power, but make sure you have to have an overcome protection device for them. You can operate, but you have to size the overcome protection device separately for each one of them. In 2011 only, this is brand new, guys, never been. In 2011, they came up and they said you have to have a disconnect for the transformer. Before 2011, you did not need to have a disconnect for transformer. Now more transformers. Only in 2011, they require every transformer to have a disconnect. Means, okay, who cares? Now the disconnect means must be within sight of the transformer, or if it's not within sight of the transformer, it has to be able to be locked in the open position. You have to be able to lock that transformer, disconnect in the open position. And if it's not within sight, you have to have a label right at the transformer to tell you the location of the disconnect for that transformer.
So that all this requirement is 2011. Before 2011, it did not exist. There is exception. Do you guys do low voltage? We have low voltage people who do low voltage fire alarm for security phone data. Yeah. Your tiny little class 2 and class 3 transformer are exempt, so don't worry about that. I know you're not going to sleep tonight because of that, but the control transformer for class 2 and 3 circuits, control and signaling circuits are exempt. So this is really not going to add anything to what we do. Most of the time, guys, when you have a transformer, you have it coming from here through a circuit breaker, right, sitting here for this panel and coming and fed from a transformer. So what they're talking about, this circuit breaker here, if it's not within sight of that transformer, then it has to be able to be locked in open position, and I have to go put a nameplate right here that indicate the location of that circuit breaker. I think it's a good idea, right? I don't know how many of you, if you get into a big plant, guys, and you walk around, there is a transformer. Where is it fit from? So you have to follow up the conduit, right? So hopefully in the future, not now, everything is grandfathered in. You'll look at this transformer and it says panel number 15. That's all it says. Feeder coming from panel number 15. You go to 15, there's a directory in panel. It should be a directory for panel number 15. It says transformer number 1. So tie the two together. So you lock it, you tag it. If it's not within sight, then you go work on your equipment. Work on it. So that was completely for you in 2011. These are the only two things that we picked guys for you in the transformer department. Any question about that? Before the time catch me, everybody sign. Make sure you sign in here to get your credits. Make sure you guys have. I see people don't have a license number here. If you don't have a license number, don't have it at all, that's not a big deal. But if you don't have it on you, I have my business card. I gave my business card. Please email me and I'll add your business card. Make sure you write your name with it. Okay? Everybody's okay? I see a few, the ones who don't have a license number right now will not get credit without a license number. Or if you don't have a license, you don't care, that's not a big deal. Everybody knows that? It's a big deal. Last time you guys had a problem, did you? You don't want this to happen. I give you my business cards, so email me as soon as you can, and I'll fill them. Okay, capacitors. Do you guys use capacitors? Capacitors are notoriously famous. You have a problem with voltage power factor correction. You guys have tons of chillers and air handling units and rooftop units and machines. And these machines, every time you have a coil, it screws up your power factor, brings the power factor down. Who cares if, are you Excel here? No. What's your utility? RPU? RB.
RP, Rochester Public Utilities.
Rochester Public, RPU, Rochester Public Utilities. So those guys will, I don't know how they do this, they penalize you if you go below 90% Excel anyway. Is that 90% the cutoff? So what happens if you have power factor low, so you add capacitors. I'm done with you. We have a bank of capacitors right next to our 3000 amp switchgear 480, and these are always energized because of our chillers and air handling units. So they keep energizing them. That's what the capacitors are. But the capacitors, guys, you have to have a means of discharging stored energy. If you get zapped, anybody get zapped by a capacitor? So be very careful with the capacitors. They store energy and they could be lethal, bigger capacitors. So they're supposed to have a means of discharging them. There's a time of discharge, guys. Within 1 minute, it should reduce the voltage from 250 volt or less within 1 minute after the capacitor has been disconnected. So that's the means of discharge. Discharge shall be permanently connected to the terminals of the capacitor or the capacitor band, or provided with an auto means of connecting it to the terminal of the capacitor band on removal of the voltage. You remove the voltage, it should lock you into a bank of resistors that burn this energy into that bank of resistors. Also, manual means of switching or connecting the discharge shall not be used. Shall not be used. I'm sure probably you guys are grandfather then. The new capacitors, you de-energize that capacitor by the action of the energizing it locked that capacitor to a bank of resistors and burned this energy right through it, so it doesn't zap you. Any comments, any questions about that? When it comes to the capacitor? Okay, capacitor sizing, conductors. I don't know how many you guys size. Here's a capacitor, here's a fuse, and I want to put my disconnect right here. Capacitor, and here's my capacitor bank here. My capacitor bank down in here. This is how you size the disconnect, the conductor here. If it was 100 amp, I like the 100. You can see I like the 100 amp because it's easier to. If you have 100 amp, not less than 135 amp rated. So the conductor have to be 135 amp conductor. If it's 100 amp capacitor, 135 amp conductor, go to the table that I showed you on the 75-degree column, size your conductor. Done. How about the fuse? The fuse, they tell you guys the fuse have to be as small as low as possible. I usually size them best to match the overcome protection device. So I size my conductor 135. It's not a standard fuse. You're going to go down to 125 is a standard fuse. So I can put 125 amp fuse on that baby. Okay, so that's basically a few things, guys, about the capacitors. Sizing the conductors for the capacitors. Overcome protection device, you have to put on every phase fuse or a circuit breaker. We size that. It says overcome shall be as low as practical. Now define practical for me. That's how the code doesn't say what multiplier. I use in my projects, I use the same 1.35 and I go down to front standard. That's as practical. It works and it works good. So, okay. So rating. If you have, there are two ways of correcting the power factor. We have 10 minutes here. Two ways of correcting the power factor, guys. You can correct the power. The cheapest way is to go to the switch gear and have bank of capacitors tied to the switch gear. That's the cheapest, easiest way. And every time you energize the loads, that you can either maintain them on at all times, or you can control part of them can go on and off based on the load or the voltage drop. That's the cheapest way. The best way is to go down to the offenders and have a bank of capacitors right next to them. For example, when we did wastewater treatment plants, every 30 horsepower motor or more, we always specify a capacitor bank right next to it in the MCC. So right at the top of the MCC, we put a capacitor. If you have a 30 horsepower, 480 or more, it's standardized with a capacitor bank. So when this motor goes on, turn on, the capacitor will turn on and mitigate the power factor. So the motor pull the power factor down, capacitor pull it up, as if no effect on the power system of this. So if you do that, if you add the capacitor to the motor, then setting of motor overload device based on the improved power factor. Now if you do it this way, then what happens to the current of the motor? The current, if the power factor goes up, guys, the current goes down on the motor. So you have to go there and adjust your power factor setting. That's what they're saying here. If you correct down to the level of a motor, right next to the motor is here, I tie the capacitor right to the load side of the disconnect means of the motor. At that point, you have to correct the power factor. And in terms of conductors, don't worry about the conductors. Don't do anything with the conductors, just the overload. And what we're trying to say here, guys, is here's a fuse, here's a disconnect, right? And here's my overload. And here's my Mr. Motor. I'm here. And right on the load side of the motor, I went and I added a capacitor bank. I can do that. I tie it. So you can see I forgot to show the controller here. They will have a controller. So every time you push the button, you energize the motor, and at the same time you energize the capacitor bank with it. Now in this case, the overload here will be seeing the improved power factor. So the current right here might be 10. And that could be easily, look at this, the current right in this area can be 10.
By the time it reached this point right here, at this point, it's actually 8. Because I corrected the power factor, I reduced the amps. So now overcontraction here, the overload had to be sized based on 8, not the 10. That makes sense. Any comments, guys? Any questions? That's only if you put the capacitor back here. What if you grab the capacitor and you put it right here? Then the overload is not going to be able to see it. The corrected factor. But what they're saying is the conductors, don't worry about the conductors, leave them as is. Capacitors are sized in kVARs, unlike anything else that you guys have seen, always sized in kVARs, not in kVAs. kVArs. In 2011, they came up with us. Okay, that's all about capacitor, guys. Any question about capacitors? You guys want to stay here until 8 o'clock so we can cover the hazard dissipation? No, thank you. No, oops. In 2011, because of renewable energy, solar system, wind, we have a new article about wind now in the NEC book. A whole article, brand new in 2011. Because of all of this, they introduced a definition of what is a battery system. You guys have data center here, so you know what a battery system is. You store a lot of energy in it. But the battery system is not just the batteries itself, the wires in between them, the charging, the overconduction device, the disconnect for the battery system, as well as the battery charger. All this together make the battery system. And that's what they came up with this in 2011. Since we use AC primarily in the US and elsewhere, AC is the dominant power system. So you have to always include the inverter and the converter. You convert to DC and you invert back to AC. That's always what we do. We have to inverter, converter, all this together. Battery charger, inverter, converter. Like in data centers, guys, as you know, you have your UPS system, right? You bring in the AC, you convert it to DC, tie your DC battery in it, so you can store it for 15 minutes, and then you invert it back to AC and dump it across your servers. Upon the loss of power, you have 15 minutes to shut down your system safely or start your generator back up. Okay, and then so they have the definition of that one, and they get a couple of voltage of the batteries based on the number and the type of the cells, what's the voltage, and they have a couple of examples. IN is information note. If you're not familiar with it, anybody's familiar with fine print note? Anybody familiar with that term, fine print note? If you're not familiar with it, don't worry about it, it's gone. They changed it only in 2011 to call it IN, information note, on informational note. So they're just explaining how they calculated the voltage based on 2 volt per cell for certain, or 1.2 volt for another type, or 4 volts for a third type. So that based on how you make the batteries, you can find the cells based on the batteries. You have to have a disconnect to disconnect the ungrounded from a stationary system over 50. So you have 660 volt DC system. You have to provide a disconnect for the batteries. Disconnect shall be readily accessible and located within sight of the battery system, but does not have to be in the battery room. You can put it within sight, but not in the battery room. Located within sight of the battery system. And I think, okay, battery ventilation. Batteries, guys, their gases come out of the batteries, so we have to have certain ventilation going on. You don't want accumulation of explosive mixtures and so forth. I'm sure you guys have a bank of battery soaks exactly like this one with battery DC. Okay, I'm going to stop right here because that will take me to the hazard dissipation. 2 things, guys. I invite you to review this one, please, and look at it. And I'm going to test you guys online with this. I will wish you guys good luck with your exam when you sit for it, and I invite you, before you leave, I want you to do some evaluation, guys, in the class. But I really invite you to visit my YouTube channel, especially when you are closer to sitting for your journal exam. You'll find some good stuff. Before you leave, could you please take a few seconds? Number 1, make sure you sign in. Number 2, could you please take a few seconds to evaluate the class? I really appreciate it. If you have anything bad to say about it, right next to it, Jeff Keldrick. Anything good, check here, will you? Talk about honesty, huh?
There you go. Anybody wants an extra copy? I have a couple of extra copies here to give to a friend or colleague or something. Okay, thank you guys. Anybody want a business card?
I pass my business cards
When will you post the,
tonight. Tonight.
oh, man, what are you doing?